Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at using trigonometry to find an unknown angle. So we learned last time, which is just revision, that there are three ratios you need to know, and you can remember the acronym SOHCAHTOA. So remember, it means sine is used when you have opposite and hypotenuse, cos when you have adjacent and hypotenuse, and tan when you have opposite and adjacent. So you actually use sine, cos, or tan, as we did in the previous lesson, when you're finding a side. We already know how to do that. But when you're finding an angle, you actually use sine inverse, cos inverse. That's what the little one means, inverse. Or tan inverse when you're finding an angle. So how you get them on your calculator, most calculators you either press shift or second function and then the required ratio. So tan inverse you press shift and then tan, cos inverse you press shift and then cos, and so on. So we're going to now look at finding an unknown angle in a right angled triangle. So to do that you need two sides. So when you're using like Pythagoras, you don't find angles, you find sides. So trigonometry and Pythagoras sort of go hand in hand. Let's look at an example. So let's say I have this triangle here. I'll say this side is 18, this is 13, and we want to find this angle theta. So we figure out which ratio am I going to use. Well, 13 is adjacent, 18 is opposite. So which one involves opposite and adjacent? Oh, that's tan. We don't use tan though, we use tan inverse. So theta, I should say, equals tan inverse of, because opposite is listed first, opposite goes on top. So it's opposite over adjacent. So make sure your calculator's in degrees. The answer you get should be about 54 degrees. So if the adjacent side's 13 and the opposite is 18, then the angle is about 54 degrees. Okay, that's to the nearest whole number. The actual answer is 54.16, but I gave it to the nearest whole number. It's as easy as that, and we're done. Let's look at another example. So let's say now I have this angle here, and let's say this sides 11 and 15. So again, which ratio am I going to use? Well, I have the hypotenuse and opposite. That one is, of course, sine. So theta will be not sine, but sine inverse. Now, it's important we get the right number on top. If you did sine inverse of 15 over 11, you'd get an error, because you can't have the opposite side being longer than the hypotenuse. So it's sine inverse of 11 over 15. Again, make sure you've got that D at the top of your calculator that tells you you're in degrees mode. So sine inverse of 11 over 15 to the nearest degree again is 47 degrees. How easy is that? All right, this has been the luckiest maths teacher in the world. Have a great day.